Yeah, good day. This is Mr. McRoy. So today we shall be looking at a very important topic in mathematics. The topic is number base. It's a topic that students do in their early secondary school years, and I'll be breaking it down to the simplest way possible for you to understand. Now, what is number base? Number base is a system of writing numbers. It's a system of writing numbers, right? There won't be too much talk so that you understand what it's all about. Okay, so in our daily calculations, when you multiply, you times, our daily calculation is in base 10. Yeah, when you multiply, you add numbers, our normal calculation is always in base 10. But there are other bases. It can be base 2, it can be base 3, base 4, base 5, base 6. Okay, so when you want to write a number in a particular base, you must make sure that you don't use digits up to the base. For example, when you want to write number in base 6, you must only use digits between 0 to 5. You must not use any digit that is bigger than the base. If you want to write number in base 9, you can only use digits from 0 to 8. Anything up to the base or above the base, you divide by the base. Okay? Yeah. Alright, so let's look at some mathematical question in number base. Example 1. The first question we're looking at is how to convert from base 2, base 3, base 4, any base to base 10. Convert 1101 base 2 to base 10. Convert from base 2 to base 10. If you want to convert to base 10, multiply each of the digits by the base. Yeah, that's how you do it. So you say 1 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2. And then you give the base power from the back in increasing order from 0, from the last one, 0, 1, 2, 3. Now, what is 2 raised to the power 3 is 8. That's 2 times 2 times 2. 2 in 3 places multiplied. That's 8. 8 times 1 is 8. Plus 2 raised to the power 2 is 2 raised to the power 2. Is 4. 4 times 1 is 4. Plus 2 raised to the power 1 is 2. 2 times 0 is 0. 2 raised to the power 0 is 1. Anything raised to the power of 0 is 1. 5 raised to the power 0, 1. 4 raised to the power 0, 1. Anything to the power of 0 is 1. So 2 raised to the power 0 is 1. 1 times 1 is 1. And this will give you 8 plus 4 is 12. Plus 0 plus 1, that's 13. 13 base 10. 13 base 10, right? This is how you convert from base 2 to base 10. So we'll look at another question from maybe base 5 to base 10 or base 6 to base 10. Okay, so let's try another question. Convert 2, 3, 4 base 5 to base 10. 2, 3, 4 base 5 to base 10. The same format. Multiply each of the digits by the base. 2 times 5 plus 3 times 5 plus 4 times 5. And then you add all of them. But remember to put the power on the base from the last one in increasing order. So 0, 1, 2. Always start from 0. 5 raised to the power 2 is 25. 25 times 2 is 50. Plus 5 raised to the power 1 is 5. 5 times 3 is 15. Plus 5 raised to the power 0 is 1. 1 times 4 is 4. And that will give you, this is 65 plus 4, and that's 69. 69 base 10. Okay? Yeah. Okay, so another question we're looking at in number base is converting from base 10 to another base. Example 3, convert 78 base 10 to base 5. Convert base 10 to base 5. You can write your 5 in words. 5. So this is how you do it. 78. When you want to convert from base 10 to another base, you divide by the base you want to convert to. That's how it's been done. From base 10 to another base, you divide. So because we're converting to base 5, you divide by 5. So 5 and 78, step by step. Be careful not to make any mistake. 5 and 7 is 1, remember 2. 5 and 28 is 5, remember 3. Now 5 and 15 is 3, remember what? 0. So you're writing your remainder here. the remainder here. 5 and 3 cannot go, 0, remainder 3. This comes down here because it cannot go in, 5 cannot go in 3. So you write your number from the lowest to the uppermost, start from down, up. This is 303 base 5. So 78 base 10 is 303 base 5, alright? Now look at another question. Okay, another question we're looking at is convert 50 base 10 to base 4. Base 10 to base 4, right? So you divide by 4. This is 50 divided by 4. Remember to write your remainders here. 4 in 50 is 12. Remainder 2. 4 in 12 is what? 3. Remainder 0. And 4 in 3 is 0. Remainder 3. The moment a number cannot go in the other number, please, is 0. Then the remainder will be that number that it divides. So 4 in 3 is 0. Bring down the 3 here. So you write it from down upward. And that's 302 base 4. 302 base 4, okay? Yeah. Okay, so another kind of question we're looking at a number base is addition and subtraction. Example, if you're given 3112 base 5 plus 4133 base 5. Yeah. So this is how you write it. You arrange it 3112 and then 4113. You start from the back. We are writing the second number. So this is addition in base 5. Remember I told you, when you're solving any question in base 5, you must make sure you don't write any digits up to 5. 2 plus 3 is 5. We can't write 5 here. So you divide. 5 divided by the base, which is 5, is 1. Write the 1 here, remainder 0. So what you'll be writing down here is the remainder, right? So 1 plus 1 is 2 plus 3. That's 5. Divided by 5, 1 remainder 0. 1 plus 1 plus 1 is 3. It's not to the base 5, so you can write it 3. 3 plus 4 is 7. Divided by 5, 1 remainder 2. And then this one will bring it down. So that's the answer in base 5, right? Also, we can do subtraction. Subtraction. Example, 50013 base 7 minus 435 base 7. You're going to subtract 2 of them. So this is how you write it. 50013 and 53. You write it from the back so that it will be well arranged. And this is subtraction in base 7. 3 minus 5, that can't go. So you have to borrow from the next number. The thing about subtraction in base is that each number you borrow has the value of the base. So when you borrow 1 from here, that 1 comes to 7. 7 plus 3 is 10. 10 minus 5 is 5. You borrow this one, so here is remaining 0. You can't borrow from here, you can't borrow from here. So you borrow 1 from 5, add it to this 0. That one you're borrowing is 7. Add it to 0, that's 7. You borrow 1 from the 7, add it to the next number, that's 7 again. So you borrow 1 from this 7, add it to this 0, here is 0. 7 plus 0 is 7, 7 minus 3 is 4. Here is remaining 6. Yes, if you follow the borrowing process, you know that here is remaining 6. 6 minus 4 is 2. Here 2 is remaining 6, because after we borrowed 1, we added here, we borrowed 1 from it again. So here is 6. 6 minus 0 is 6. And here we borrowed 1 from 5, so here is remaining 4. It's not confusing at all. Let's go through the process again, right? Also, we could try another question. If you're given 5, 3, 2, 4, base 6, minus 4, 5, 4, base 6, 5, 3, 2, 4, 4, 5, 4. And this is subtraction in base 6. 4 minus 4 is 0. No problem with that. 2 minus 5, that can go. So we'll have to borrow again. You borrow from this. And when you borrow 1 from this and add it here, that value, the value of the 1 borrowed returns to the base, which is 6. 6 plus 2 is 8. 8 minus 5 is 3. Here is remaining 2. 2 minus 4 can go. So you borrow 1 from here. 1 turns to 6. 6 plus 2, 8. 8 minus 4 is 4. And here's remaining 4. You bring it down. So there's nothing here. You can put 0 here. So maybe you can fill up the missing spaces with 0 in case of next time. So 4 minus 0 is 4. Alright? Yeah. Okay, so that is that for today. Number base. You can perfect your solving of number base by practicing more questions. Yes, please endeavor to do that. It makes you perfect. Solve as many questions as possible. They all follow the same basic principle, all right? And next time we're looking at other maths topics, as well as topics in other subjects. Always check our page and subscribe as well. If you have any question, please leave a comment below, all right? See you next time. McRoy.